So when we're doing factorizing, first of all, you're going to look for a highest common factor. But the next thing you're going to do is look and see if there's a difference of two squares. So an algebraic expression of the type x squared minus y squared is called a difference of two squares. And so we've got this relationship here, x squared minus y squared equals x plus y upon x minus y. Now if we expand that bracket and do our FOIL, so we do x multiplied by x is going to give us x squared. Then if we do x multiplied by negative y is a negative, and remember we put our letters in alphabetical order. That way we can make sure if we've got anything that's going to be able to be cancelled out or gathered together. And then we're going to have the plus y multiplied by x is going to give us a plus xy. And then we're going to have negative y multiplied by that positive y is going to give us negative y squared. Now we've got some like terms which are obvious because we've written them in alphabetical order, and you can see there we've got a negative xy plus an xy, so they cancel each other out. So this gives us our final answer, which is x squared minus y squared. So basically the first term in each of our brackets is the square root of the first term in our difference of two squares, and the second term of our brackets is the square root of the second term of our difference of two squares, and one of our brackets is going to be positive, a plus, and one of our brackets is going to be a negative, so it's going to be take away. So let's have a look at an example. So we're going to factorize y squared minus 36. So we've got two terms, there's no highest common factor, we've got two perfect squares separated by a subtraction sign, so we know that means it's the difference of two squares. So we know that we're going to have two brackets, and one of the brackets is going to be positive and one of the brackets is going to be negative. Now the first term in each of our brackets is going to be the square root of that first term. So the square root of y squared is y. So we know that when we do y multiplied by y, we're going to get back to our y squared. The second term in each of our brackets is going to be the square root of 36. So it's going to be a 6 and a 6. So we've got y plus 6 upon y minus 6. And we can quickly just expand that just to double check. And we're going to end up with y squared minus 6y plus 6y minus 36. They cancel each other out, and so I get to back where I started. So what if there is a coefficient of the term? As long as that coefficient is something that can be square rooted and it's a perfect square, then you're going to do exactly the same thing. So we've got two perfect squares separated by a subtraction sign, so that means it's a difference of two squares. So we're going to end up with two brackets. One bracket's going to be an add, one bracket's going to be a minus, and it doesn't matter which way around you put it, because if you remember, multiplication is something called commutative, so you can do it in any order. So the first term in each of our brackets is going to be the square root of 9 and the square root of a squared. So the square root of 9 is 3 and the square root of a squared is a. So we're going to have a 3a in the beginning of both of our brackets. And then the second term of our brackets is going to be the square root of 100 and the square root of b squared. So the square root of 100 is 10 and the square root of b squared is b. And if we expand that out, we're going to get 9a squared, take away 30b plus 30ab, and then take away 100b squared. So we've got the negative 30ab and the positive 30ab cancel each other out, and so we end up back where we started with our 9a squared minus 100b squared. It's exactly the same thing if you've got letters, as long as they're positive powers, so this could be p to the power of 4 and q to the power of 4, take away j to the power of 4 and k to the power of 4, as long as you can perfectly square it then you can end up with a difference of two squares. So we're going to have two brackets. One's positive, one's negative. We're going to square root the p squared and get a p, and we're going to square root the q squared and get a q. And that's going to be the first term in both of our brackets. We're going to square root the j squared and get j. We're going to square root k squared and get k, and that's going to be the second term in both of our brackets. So the answer to p squared q squared minus j squared k squared is pq plus jk upon pq minus jk. Now sometimes you're going to have to do more than one step. So when you look at this, it looks like it should be a difference of two squares, but 98 and 242 are definitely not perfect squares. However, they're both even numbers, so we can take out a highest common factor first. So the highest common factor of 98 and 242 is 2. So we're going to take out a common 2. And that means that our bracket becomes 49d squared minus 121. And you can see that now we do have two perfect squares. So we have a second line of our working out, which is going to be 2. We're going to have two brackets for our difference of two squares. One's going to be positive, one's going to be negative. And then we're going to have to do our square rooting. So the square root of 49 is 7. And the square root of d squared is d. And we've got the square root of 121 is 11. And so that's our second term. So 98d squared minus 242 is 2 upon 7d plus 11 upon 7d minus 11. Note in exam questions, these questions will be worth 2 marks, and so that's a hint that you're going to have to do two things. So it's not just a case of taking out a highest common factor and then leaving the 49d squared minus 121. You need to make sure that if you've got two terms, just double check if there is a perfect square there.